importance to supporting climate-sensitive social and economic development sectors. The meeting committed itself to strengthen and sustain national meteorological and hydrological services by providing them with all necessary resources and adequate institutional framework to enable them to fully perform their roles as a fundamental component of the national development infrastructure of countries. And this meeting of ministers in charge of meteorology was necessitated because of the fact that in Africa, the hydrological network is very poor, because issues hardly need reach ministerial level. And we thought that if the ministers of governments are involved, then I think the meteorological service infrastructure will grow. And this actually happened immediately after this meeting. We saw that many countries in Africa developed their meteorological infrastructure. The meeting agreed to establish an African Ministerial Conference on Meteorology, which is AMCOMET in short, as a high-level mechanism for the development of meteorology and its application in Africa. The meeting also decided to develop an African strategy on meteorology for enhancing cooperation between African countries to strengthen the capabilities of their national meteorological and hydrological services and existing regional and sub-regional climate centers. The African Union, whose headquarters in Addis Ababa, Ethiopia, are the heads of state and governments, they met in Ethiopia and endorsed this declaration, establishing AMCOMET with a bureau and a task force. The other policy, Mr. Chairman, is the East African Community Climate Change Policy. It was developed as a result of the directive by the heads of state of the 5 East African Community partner states. East African Community is made up of Kenya, Uganda, Tanzania, Rwanda, and Burundi. And this was to address the adverse impacts of climate change in the region. The overall objective is to guide partner states and other stakeholders on the preparation, implementation of collective measures to address climate change in the region while assuring sustainable social and economic development. It was realized you can't go it alone. So these 5 countries come together to have a policy that will help them work collectively to address this issue. In conclusion, Mr. Chairman, we note that weather and climate is critical in efforts aimed at socio-economic development, disaster risk reduction, and poverty alleviation. Natural disasters that devastate many economies are highly related to weather and climate. Early warning information is therefore paramount in planning and preparedness to reduce the impacts of extreme weather and climate events. Issues of climate change and variability must be mainstreamed into policies formulated for national planning and programs to help build the resilience of vulnerable communities to adopt and cope to extreme climate extremes. Formulation and adoption of appropriate climate change policies will ensure that climate information effectively contributes to sustainable socio-economic development, environmental conservation, including alleviation of poverty in Kenya and Africa. Lastly, I think is the global framework of climate services, which is a new come up newly by WMO and other organizations. This framework will also address the issues of climate in Africa. And I think it's a very good initiative and framework that will see adoption of climate and use of climate information in decision making. Thank you all for your kind attention.
Thank you very much, Dr. Mukabana, for your informative presentation. Before I request next speaker, I was informed by Secretariat that everybody who has posted presentation invite to register during the break. Now, I may request Dr. Paulo, Dr. Joseph,
Извините, был не очень точный перевод. Все, у кого есть постерные презентации, я на русский перевожу, должны зарегистрироваться во время перерыва. Спасибо.
I may invite Dr. Paolo Albrito, Regional Coordinator Europe, United Nations ISDR, on title Governance of Climate Change, Adaptation and Disaster Risk Reduction in Europe. Please, you have the floor.
Thank you very much. Good morning, everybody. It is a pleasure to be here with you today. My name is Paola Albrito, and I am the head of the Europe office of the UNISDR, which is the International Strategy for Disaster Reduction. Today, I'm going to share with you some findings that are emerging from a publication that we conducted in Europe, which is called Climate Change Adaptation and Disaster Risk Reduction. And I will put emphasis on the subtitle, which is a review of risk governance. As we heard yesterday, there is a big difference between governance and government. Professor Pachauri indicated clearly that when we're talking about governance, we are talking about a process, first of all, that includes a number of different actors looking at a number of priorities. And mostly, he mentioned the importance of three groups which are part of governance, which are government, private sector, and civil society. So the review is actually looking at the governance, not at government only. In undertaking this study in Europe, it also emerges that there are a number of key issues of governance in climate change adaptation and disaster risk reduction that are related to policy. So what is a good policy? Well, it's been identified as a multi-sectoral framework for disaster risk reduction and climate change adaptation. Basically, the policy needs to embrace a number of different aspects that are related to the topic, but mostly it needs to be created based on some information. And therefore, the first step is the undertaking of risk identification and assessments. But also planning, extremely important. We learned from the review that in many occasions, planning related to climate change adaptation and disaster risk reduction are still somehow separate. There are different reviews, different documents prepared. Combining the two aspects is extremely important in order to create a natural relation among adaptation and risk reduction. Legal and regulatory framework. The review again highlighted that legal framework are actually the first step for government in order to provide solid basis for policy and cooperation at the national level. Resource and fundings. I think yesterday, again, Professor Pachauri, but also Ms. Wormström, touched base on the issue of resources and funding at the national level. Very often it's mentioned as a capacity, need of capacity development. But in fact, the reality is that if we do not allocate sufficient resources, it's not going to be possible to address the many challenges that we are faced in this particular sector. And then organization and structure. I'm going to be talking a little bit later on the importance of structures at the national level in order to embrace disaster risk reduction and climate change adaptation. So the main elements that are going to be reviewed are related to flood of information. What we will see is that, in fact, informations are available, but how they are shared in this context is still need to be fine-tuned. But also issue of accountability, where we're standing in terms of main stakeholders and framework. And then there are a number of key issues that are emerging in terms of communication, capacity building, national platform, and knowledge and information management. If we're looking at the flow of information, we have learned and we are familiar with the fact that there are a number of data available. And again, as mentioned yesterday, also by Professor Frolov, data is available, but mainly addressing overall global information, which creates some discrepancy if we are looking, in fact, at what is happening at the national level, what is the national reality in terms of data. Therefore, the access and usability of data is still a challenge. But by looking at data, there is another issue that is emerging in the review, which is the compatibility of data. What happens, and this is very often the case in Europe, is that we have detailed information on a particular region, for instance in France, but there will be great difficulties in order to compare that data with other countries in Europe. So the necessity of developing same methodology in order to collect data is extremely important. And this has been highlighted vis-à-vis the European Commission and the EU. And in fact, in 2009, the EC adopted a communication on disaster prevention that clearly highlights the needs of standardization of data in the European context. Lack of communication in relevant knowledge network is still a challenge. What we've seen in the review is that there are different networks that are sharing information. But in fact, these networks do not communicate among each other. Classical challenge is the scientific community. Probably there are networks, actually there are networks in Europe from the scientific community side. They are sharing information among themselves, but very rarely they are going to be sharing information with other groups, such as, for instance, capacity development institutions that are looking at the issue of disaster risk reduction, or other sort of networks, such as spontaneous NGO networks. Policy programs and projects created with little coordination. This is another issue. We know that the Commission, through DG Research in particular, has been addressing a number of policy and programs projects. What is happening is that very often the information among the different institutions that are part of this project and program are not as frequent, are not shared as much as it would be needed. And of course, there are conflicting definition and working language. Yesterday, again, in the opening, there was reference made on the fact that we need to use the appropriate terminology when we're talking about disaster risk reduction, and sometimes this terminology is different when we're talking about climate change. So obviously, this creates a sort of necessity to have a common ontology when we're looking at adaptation and risk reduction. And of course, the multilingual barriers, especially in terms of research, which is something that has emerged very much in the European context. When we're looking at accountability, what the review has pointed out is that, in fact, yes, governments should be responsible in terms of climate change adaptation and disaster risk reduction. But also, reality is that people are often judging governments based on their ability for disaster management and recovery. Why? Because they lack, in many occasions, the understanding that risk of disasters can be reduced and adaptation can take place. And also, the second reality is that disasters are complex processes. So it is very difficult to link a single action to an actor and its accountability. By looking at the picture in Europe and the main European actors, what has emerged is a quite comprehensive situation and number of different involved actors. In terms of global institutions, we do have the UN, the IPCC, ISDR, and also a number of frameworks. The HFA, Hyogo Framework for Action, we mentioned yesterday, that is a main tool in order to adapt to climate change, and of course the Cancun Adaptation Framework. European policy institutions are there. They are looking at coordination and directives, and they're working with the member states. In particular, in the European context, DG Klima and DG Research are very active in order to combine these two communities. And then there are European research institutions that are looking at applying research in training and applications. Among them, there is the European Environmental Agency and the Joint Research Center. This slide captures a little bit the number of frameworks that are available. The European funding programs, I'm not going to go into details now, but in the context of the Commission, there have been a number of programs that have been made available for European countries or in partnership with other countries in order to access funds, and the different category of project. And what we see, in fact, that when we're looking at the category of projects, we do have a broad portfolio and possibility in order to address adaptation and disaster risk reduction. Now, the review has highlighted a number of key issues that needs to be addressed in order to properly look at the governance of adaptation and disaster risk reduction. In terms of communication, UNISDR is put here as first, but in fact is not in relation to UNISDR itself, but actually is in relation to the number of information that we are collecting in the European context in terms of adaptation and disaster risk reduction. You might be familiar with the Prevention Web. What the publication is implying is to use more Prevention Web, is to use more UNISDR or UNISDR to be more active in order to share this sort of information. The inclusion of policy makers at outlets of CCA and DRR in terms of national and regional interventions. What we have very often realized is that there is a discrepancy between the policymakers and the climate change adaptation and disaster risk reduction reflection. Somehow they're entering into the picture at a later stage, and in fact they should be involved from step one. Needs to be, there is a need to build upon a number of annual meetings that are organized in the European context in terms of both adaptation and disaster risk reduction. Facilitate opportunity for researchers and policymakers to exchange information. This is something that we are working very actively in Europe, not only with the Commission, but also with other institutions such as WMO. In fact, we have been working in particular in Southeastern Europe to see how we can bring together the researchers and the policymaker in order to exchange their experiences and mostly to see how they can fine-tune their language and to use the messages that are emerging from the scientific community in order to be adapted in policy development. I'm not going to go into details of all the different recommendations in terms of the communication, but I will put emphasis on one last point, which is to build on opportunity that are already existing in terms of sharing information in the European context. And one opportunity is related to the campaign on making city resilience. What we have identified in Europe is the fact that very often citizens that should be involved in risk reduction and adaptation measures are not familiar with the topic. And actually involving the local level in a number of activities is extremely beneficial to build a bottom-up approach. So the use of the campaign is one of the recommendations made. Capacity building. Capacity building is being highlighted in a number of meeting events and also in the review. But the review has indicated that overall there have been a great variety of workshops that have been organized in Europe related to climate change adaptation and disaster risk reduction. But what is actually missing is a specific focus on a number of topics. The subject per se can be extremely broad, so the need of focus in the agenda and the preparation of such workshop, it would be extremely beneficial. Second aspect in terms of capacity buildings comes again from the root within the educational system. The inclusion of risk reduction knowledge and climate change and adaptation in school curricula, it will be extremely beneficial in order to raise awareness and knowledge of the population on this phenomenon. Fund project and facilitate good communication and practices. And I think in this aspect, in particular in Europe, there is a lot of emphasis put on the issue of economic disaster prevention. Build a common understanding of concepts relevant to climate change adaptation and disaster risk reduction. We already touched base on this particular aspect. And the importance of convening multi-actor process in order to ensure that disaster risk reduction and adaptation includes all necessary actors. And on this regard, we are going to be talking a little bit about the national platform. Dr. Mukabana, in his previous presentation, really presented an excellent overview on how disaster risk reduction and adaptation includes a number of sectors. It is extremely multi-sectoral by nature, and also a number of actors that need to be involved in this process. How to bring these actors together, it is extremely challenging. At the same time, if we do not bring them together, we are not going to have the full picture and the full action when we're talking about adaptation to climate change and risk reduction. For these purposes, the Hyogo Framework for Action has highlighted a key mechanism to bring these actors together, which is called national platforms. So the national platforms serves as a body to coordinate disaster risk reduction issues, and in this context really can play an extremely important role in order to bring together the policymakers, the line ministers, together with the researchers in order to look at adaptation and disaster risk reduction. They can play an active role in research by linking steering committee and major projects, and they can really help create partnership among research communities, governments, and the private sector that is also part of the national platform. Overall, worldwide, we have 81 national platforms as per today, of which 22 are in Europe. One important message is actually to ensure that these coordination mechanisms are established. Again, through the collaboration with WMO, we have succeeded in order to ensure that in national platform in Europe, we have the important presence of the Hydromet Institute that are contributing in providing key relevant data and also scientific community, therefore scientific knowledge, to the different line ministers that are going to be looking on how to develop the work plan in order to address the topic. And then knowledge and information management. Well, as pointed out previously in the presentation, there are some gaps that needs to be addressed in this context. One suggestion, which is something that the Commission is also working upon, is in order to translate information and material. Very often, we learn that there are extremely important lessons learned at the national level, but this information are not translated in other languages or in English in order to be shared in the regional or international context. So communication and language translation is still an important aspect that needs to be addressed. Also, increased support to community-based climate change adaptation and disaster risk reduction in order to share information that is stemming from the local level. Another important aspect of the review, we learned in Europe that lessons learned at the local level are extremely important because they succeeded in order to involve the citizen in being an active player in adaptation and risk reduction. And very often there are the lessons learned that are less known in the regional and international context. Well, I will stop here because probably I've been talking over 20 minutes, but I would like to invite you to look at the publication. It's available on the website, and I've got a few copies here with me if you're interested. And thank you very much for your attention.
Thank you very much, Madame Paolo Albrieto, for your comprehensive presentation about UNISDR activities in Europe on issues of adaptation and disaster risk reduction. May I invite next speaker, Dr. James Snyder from WWF Canada on title Rapid Assessment of Circum-Arctic Ecosystem Resilience, a framework and tools to guide ecosystem adaptation measures under major climate change. Please.
Hello and thank you. My name is James Snyder, and I'm here on behalf of the World Wildlife Fund to present a project from our Global Arctic Program titled RACER, which is a rapid assessment of circum-Arctic ecosystem resilience. I would like to acknowledge first my colleagues in the Global Arctic Program, as well as WWF US and WWF Russia, and now I will dive into the presentation. Before going into the gritty details of the RACER project, I'd like to step back for a second and revisit the context of the challenge ahead of us. As we saw yesterday, our current commitments are trending towards an increase of 3 degrees Celsius around the world by 2100. This magnitude of change is consistent with the SRES A2 scenario, which is depicted here. What's significant, and what I'd like you to take away from this slide, is that most of these changes are most significant within the Arctic system. As you can see, we might see a 7-degree warming by 2100 within the Arctic. This is significant for both terrestrial and aquatic ecosystems in the circumpolar Arctic. One, based on permafrost. As you see here, we're expecting drastic reductions in permafrost. On the left, this is until 1999, and on the right, predicted changes to 2100. Both the extent and depth of permafrost is expected to change significantly, which has consequences for the terrestrial ecosystem, both in terms of the hydrology of the system, soil formation, and the impacts on the vegetation community, which of course will have impacts in terms of the higher trophic structure of those ecosystems. Similarly, in the marine environment, we expect drastic reductions in sea ice, as illustrated here. This paper from 2009 implies a drastic reduction in sea ice in the bottom right corner. You see summer sea ice here. These changes are quite significant. And this is by only 30 years from now. As you would expect, the consequences of these drastic changes in sea ice will have huge impacts on marine ecosystems in terms of the productivity of those systems, food webs, species such as polar bear or walrus and other ice-dependent species, and as well as indirect effects on global climate. So, given this context, how do we manage and conserve our ecosystems under this rapid change that we presented with, especially in the Arctic? The challenge ahead of us is vast. So I present to you actually a term that has been used in both presentations previous to mine, and that is of resilience. And so we posit that by building resilience in our ecosystems will be the primary way by which we can effectively conserve ecosystems within a rapidly changing environment. What is significant here is that rather than being place-based, we are emphasizing the structure and function of the system. So many of you may be familiar with this diagram, maybe not, but what I will do is just quickly take you through it. So if we were to define, actually we'll use the cursor, I think it'll be easier. If we were to define an ecological system based on a valley or trough, and the parameters of that system are the edges of those valleys, a disturbance of that system will mean that the system that current system as is defined will move within that valley. However, if the function and structure of that ecosystem is significantly impacted, we will find that we'll move, there'll be a tipping point, as it's termed in English, into a new system. And so in terms of effectively conserving these ecosystems, we will emphasize the function and structure. This is a forward-looking approach and is an important step in terms of an adaptive and dynamic approach to conservation. Once again, I emphasize that this is an approach to conservation based on ecological function and structure. We are emphasizing ecological processes and drivers. What are the underlying biogeophysical drivers of the system? And how can we build and conserve those drivers such that our ecosystems are resilient in the face of drastic changes in global climate? So I present to you RACER, which is a tool and analytical framework for assessing resilience within the circumpolar Arctic system. The analytical framework that we have defined has one fundamental assumption that key features that confer resilience are based on productivity and diversity of those ecosystems, as illustrated here in the orange and red circles. We identified these areas of productivity and diversity based on a series of analyses, one from remote sensing or satellite images. Don't look at the details here, but rather we're looking at the landform heterogeneity. So this is actually the variance of the terrestrial topography in terms of defining terrestrial ecosystems. We have also completed satellite-based analyses of primary productivity, both in the marine and terrestrial ecosystems based on satellite imaging. This data here is from the CWIF sensor. On the terrestrial side, we've used the MODA sensor. And finally, we have drawn heavily on literature and expert advice to identify key features within our ecosystems. Not only have we identified these areas of high primary productivity or diversity, but we've also attempted to identify the underlying ecological processes that contribute to their significance of those areas. These drivers of exceptional productivity or diversity is illustrated here, such as wind or the formation of sea ice in the marine system, or comparatively in the terrestrial system, such as soil formation or soil moisture. These underlying drivers of the ecological system are ultimately the key features that we are identifying within the RACER project. Of significance is also our ability in looking forward and connecting these biogeophysical drivers to climatic models so that we can predict the persistence of these features into the future. I will present to you now, briefly, one of our case studies from the Beaufort Sea ecoregion, which is adjacent to Alaska and northwestern Canada in the western Arctic. On the left, in red, you see the boundaries of that marine ecoregion. This is adjacent to the Chukchi and Bering Seas in the west, and to the north, the Arctic Ocean basin. On the right, we see the major watersheds that are adjacent to the Beaufort ecoregion. Of significance is the blue area that you see here. This is the Mackenzie River Basin, which is the largest river in Canada. It drains roughly 20% of the landmass of Canada, and it's a significant river system. So now that we have you situated in terms of the Beaufort Sea ecoregion, I'd like to present to you a conceptual diagram in terms of the fundamental drivers of a marine shelf system. As you can see here, this is a complex system in terms of getting a mechanistic understanding of what the drivers are of the system. On the left, we see the drivers at play within the Arctic summer, and on the right, we see within the Arctic winter. I will frame for you some of the key features here, being formation of the sea ice, being upwelling of currents, and how those actually play together to form these marine ecosystems. I will not dwell on the details here, as I'm sure it can be difficult to see from a distance. Instead, I'd like to present to you the key regions or key features that we've identified for the Beaufort Sea ecoregion, and some examples in terms of what those areas represent. As you recall, I mentioned the Mackenzie River as being one of the primary influxes of fresh water and nutrients into the system. And based on our analysis of primary productivity, we see that there's a hotspot or bloom of productivity in the Mackenzie River Delta, which is illustrated here in that green hashing here. As well, based on our fundamental assumption that diversity or heterogeneity of the landscape is a driver of the system in terms of the fundamental characteristics of a resilient system, we've identified topographic-based features, such as the continental shelf break and inland canyon, or rather coastal canyons. Within the Arctic marine system, it also is important to note the role of sea ice, and especially polynya. So these are areas that even in the winter are open water, and these are especially important in terms of the primary productivity of those areas. As you may recall, I mentioned that within the RACER project, we are applying global climate models, general circulation models, to assess the persistence of these key features into the future, such that we can identify ecosystems that are both resilient and the key features that are conferring the resilience in that system. and whether those exceptional areas of primary productivity and heterogeneity will remain within the next within the next 100 years. Excuse me. Just quickly to present to you what these schematics represent. So we have a decadal change on what would be the y-axis here, and then we have a seasonal change across the x-axis. The change in color represents the degree of change, and this variable would be sea ice thickness. What I'd like you to take away from this is that based on the IPCC AR4 suite of models, we've brought together a suite of variables and an ensemble of those models to present the degree of change of those climatic drivers into each of these ecoregional systems. This table summarizes each of the key features that were identified within the Beaufort Sea system. I will not dare to go into each of them, but rather I will use an illustrative example of one of the features. The Barrow Canyon and its associated polynya, which I noted earlier, the main drivers of that key feature are seasonal ice cover, the benthic topography or shape of that system, the circulation of water up and down the canyon, and of course sea surface temperature. We identify those drivers in that they are the underlying processes and the basis of those features, but also do the connectivity with the global general circulation model predictions up to 2100. So SST is sea surface temperature. Also, we identify salinity as a significant climatic variable, and sea ice concentration as well. Based on the composite of those climatic models, we then make an assessment of the persistence of those features, and in this case, the persistence is high, as designated by an H. The ultimate objective of RACER, the full title of which you see at the above of this slide, is to undertake and provide a framework for evaluation of each of the 50 ecoregions, both marine or terrestrial, in the circumpolar Arctic. As you can see here, this is a vast area, and the potential undertaking is quite large. But in terms of ensuring the resilience of our Arctic ecosystems, such an undertaking is vital. I should also note that there are 4 pilot case studies that we have developed within the RACER methodology, 2 within Canada, 2 within Russia, that are the basis of the toolkit. The first, as I presented to you, the Beaufort Sea in Canada. The second, the Central Canadian Tundra. The third, the Laptev Sea in Russia. And I would like to acknowledge here the work of my colleagues at WWF Russia and the importance of the Russian Marine Arctic Atlas. That was a large component of that work for the Laptev Sea. And finally, for the Eastern Chukotka ecoregion. As I hope that I have illustrated to you, the challenge ahead of us in terms of effectively conserving and managing Arctic ecosystems within the next 50 to 100 years is quite challenging. We have a lot of work ahead of us, and I hope that the RACER framework and toolkit that we presented here will help inform and provide the tools that are necessary for that undertaking. I should note that the RACER methodology and framework and this manual or a report, as you see here, will be presented tomorrow in Sweden at the meeting of the senior Arctic officials of the Arctic Council. And so we hope that certainly that there will be uptake and utility of the RACER methodology as I presented it here. And with that, I'd like to thank you for your time.
Большое спасибо, доктор Снайдер. К сожалению, у меня у самого очень много вопросов, есть интересные презентации, но мы отстаем от нашего графика, поэтому придется, видимо, все наши, так сказать, обсуждения перенести на кофе-брейки и обеденное время. А сейчас я с удовольствием предоставляю слово доктору Али Нуриану, который нам расскажет о вызовах адаптации к изменению климата на примере исследования озера Урмия. Пожалуйста, доктор Нуриан.
Bismillah ar-Rahman ar-Rahim. First, once again, let me, on behalf of you and myself, to express my appreciation to Rus Hydromet for having organized this notable gathering on an issue that all of us are deeply concerned about. No matter where we are in the world, we are all being affected by climate change and its consequences. So finding a global problem roots and sharing the best of the solutions brought all of us from different governments, international organizations, scientific communities, universities, civil society, private sector together at this conference. Climate change issue and its consequences in RF4, assessment report number 4 and assessment report 5, and presenter have provided relevant information. So I just would like to present to you some brief information about climate change in Iran. As you see in this slide, the variation in precipitation and temperature have dramatic over the past 45, 55 years. And in this slide, you see hydrological drought index and freshwater withdrawal in different basins of Iran. We see decadal trend of wind speed. What is interesting is that wind speed is reduced in some regions and increased in some others. Within the next few slides, you will see some example of unexpected and unusual severe phenomena, which there is no record for some of them within those regions. The climate change and or other possible drivers have caused consequences such as drought and elimination on some of our lakes, wetlands, and rivers. Urumia Lake, the biggest salty lake in the Middle East, has been facing dramatic consequences of these drivers. Following 3 slides show the characteristic of Urumia Lake, basin, climate, and inflow. Here we see change in this lake from 1965 to present based on aerial picture and satellite images. Water level has been decreased along with decrease in surface area. Massive amount of salt as consequences of this drought are a great threat for freshwater, chemistry, and agriculture of the region. These changes are happening whether we like it or not, and what is important in how to cope with them. Some example of adaptation might be natural resources, public health and safety, infrastructure, tourism, and outdoor recreation. I personally belong to that part of the world which, based on political terminology, is called developing countries. But due to the fact that I am at the focal point of international related organization for almost 3 decades, I differentiate between the problem roots and the challenges of climate change adaptation of developed and developing countries. The key player in this challenging field, as a previous speaker mentioned, are government, scientific and universities, private sector, interest groups and NGOs, civil societies, and international institutions. In developing countries, these bodies mentioned are not all internally aligned in a pre-planned and coordinated path of cooperation towards overcoming the problems. And also the activities of climate change adaptation and mitigation are not nationally institutionalized. Therefore, there is not a unique strategy and coherent follow-up. Due to the political and economical situations, the environmental issues in general and climate change in particular are not among the prime priority in most of the countries. Most of these countries, I mean developing countries. And on the other hand, most of these countries haven't defined their regional and international interests for planning and cooperation. And finally, the complete and necessary information and data are not available. And the next thing in challenges is, from a practical point of view, designing local responses that simultaneously address the issues of climate change and sustainability is a challenge task. To help identify possible synergies and trade-offs between mitigation and adaptation activities, it may be useful to consider the 4 categories of interaction presented in this figure. I don't want to go on detail, just I say something brief. Activities that fall into the lower left quadrant are unsustainable, resulting in both increased greenhouse gases emissions and vulnerability to climate impacts. Activities that fall into the upper right quadrant represent the opposite conditions, activities that build on the synergy between adaptation and mitigation and reduce both climate vulnerability and greenhouse gas emission. Water conservation is an example of this type of activities, and it is also an example of sustainable development measure. The other two quadrants represent trade-off created of focusing slowly on mitigation or adaptation and consequently further increasing vulnerability or level of greenhouse gases emission. By this, designing natural response that simultaneously address the issues of climate and sustainability is a challenge task. We need to address proper answers to following issues of adaptation to climate change. How to identify the focus and objectives of adaptation and mitigation. Where are we heading now? Where do we want to be in the coming decades? How can we get there? How to address new challenges and re-examine the identified action. Together, we need to find answers to these questions which would bring initiative of adaptation and mitigation. Toward this goal, we should set up a number of conferences, as it is now, seminars, workshops, and discussion meetings to involve each and every group, such as governmental, scientists, private, representative of international community for reaching the guideline and roadmap. We need guideline and roadmap for the developing country. This roadmap and guidelines should be applicable and practical for all the users and have the following criteria. It should be interactive, because integration is very important in developing countries. Proactive, collaborative, practical, and flexible. In this regard, as previous speaker mentioned, there is difference between governance and government. But in developing countries, the government has important and key role. The government can play managing risks from climate change impact, making efficient investment decisions, maintaining a strong, flexible economy and a social safety net, leading national reform, managing national assets and programs, national science and information, creating the right condition and incentive for businesses and the community. And the regions, provinces, state, territories, and local government has different duty, different level of government have different responsibility and will therefore have different role in helping adapt to the impact of climate change and adaptation. In concluding, I wish to propose some remarks promoting the existing scientific and research capacity in the countries of the region regarding the global environment change monitoring, improve access to data and information, promoting multilateral cooperation in the region and access climate change, therefore environmental change, applying the outcomes of climate change research in the planning and policies, create structures, rules, and regulation for monitoring the changes in the countries of the region, strengthening regional environmental center, develop using advanced technologies such as space-based network, satellite applications and remote sensing, modeling, software and hardware, integrated system approach on climate change adaptation, and finally, need to find new ways to inform and involve citizens. Thank you very much.
Thank you very much, Dr. Nurian. With your help, we are coming back to our original schedule. We are just to make a break for a coffee for half an hour.